So we are actually revisiting our first episode today, and we are going to be talking about the science behind an allergic reaction. So Dr. G, let's just jump right into it. What is a food allergy?
So a food allergy is when your body's immune system overreacts to a particular food protein. So this overreaction is mediated by the immune system's production of a specific antibody called an IgE or immunoglobulin E antibodies. When you consume a food and you're allergic to it, your body releases chemicals like histamine, which lead to symptoms that can range from mild itching to a severe anaphylactic reaction.
So basically what you're telling us is that a food allergy is an immune response that's inappropriate because the food normally isn't harmful to people. But in our case, as in someone with food allergies, the body sees it as harmful and it sees it as a threat. And so the immune system goes ahead and loses its mind.
Yes. So the immune system is mistakenly identifying the food protein as a harmful substance. And then this triggers an allergic reaction or a series of chemicals being released in your body that causes a series of symptoms.
So when people talk about an anaphylactic allergy, they like to use terms like true allergy or IgE allergy. And I think the best thing to do is to start with this whole IgE. What is that? We hear that a lot. It gets thrown around on Facebook groups all the time. Can we start with what is IgE and why is that so important when we talk about allergies?
Sure. So first I want to start with what an antibody is. So an antibody is a protein in our body that helps to basically look for things that shouldn't be in our body. There are different types of antibodies that fight off bacterial infections, that fight off other types of things that we don't want in our body. And so in particular, IgE antibodies are produced by our immune system to fight off parasitic infections. So a parasite is a type of infection that can occur. It's not very common in the US or European countries, but it can be found in other parts of the world. And so when you encounter a parasite, an IgE antibody is what's going to find it and get rid of it, essentially. But we also know that IgE antibodies are involved in the allergic reaction. What happens is that our body produces IgE antibodies that are specific to certain allergens that can be found in foods or in environmental allergens. And the allergen is actually a protein in the food or the environmental thing that we're allergic to. So proteins are basically the building blocks of anything that's living. So that includes plants and animals. So trees, dogs, grasses, all of these things are made out of proteins. We're made up of proteins. And so, for example, Courtney, you are allergic to environmental allergens like trees and your dog. You're also allergic to food proteins. So each food and each environmental allergen are made up of a number of proteins, but what we've been able to do is figure out what the main protein or the predominant protein is in that food or environmental allergen that actually causes allergic disease. So when a person is allergic, their body produces a specific IgE antibody that targets that particular food protein or that particular environmental protein. And so essentially each IgE has almost like a radar for each of these different proteins in the food or the environmental allergen that each individual person is allergic to. So I don't have any food proteins that my body produces IgE antibodies to, but I am allergic to environmental allergens like cats and trees and dust mites and things like that. And so when the IgE antibody sees that allergen or that protein that it's specific for, then that causes a series of other events in the body that releases chemicals that then cause a reaction to happen.
Okay, so I feel like that was a lot. And I'd love to just kind of clarify some key things that I heard. So first thing is protein is a big term. And what you said is that proteins are the building blocks. So there's proteins found in everything, and the proteins are unique to things. So if we take me as an example, my dog has a protein that I'm allergic to, and a peanut also has its own protein, which I'm allergic to. So I'm allergic to lots of different proteins. Those proteins just happen to be found in different things, right? And so the antibodies, the IgE in my body, have special radar per protein. So there's an IgE antibody in my body that has a radar for my dog's protein, right? And then there's an IgE that has a radar for the peanut protein. And so when those proteins come into my body, the IgE sees it, and then once it sees it, releases some sort of signal for my immune system, then create this chemical reaction, which is the allergic reaction. And what you're saying is that what's amazing, actually, is that science has been able to really locate the exact proteins that people are reacting to. And I'm guessing that is exactly what happens when you get a skin prick test. They're not just rubbing you with a peanut, but they're actually skin pricking you with the protein they know is going to cause the allergic reaction. Is that right, Dr. G?
Exactly. So we figured out what those proteins are. And when we do testing, either by blood or by the skin prick test, those are the specific proteins that we're testing you for. So now I'm going to explain what happens in your body when you are an allergic person. You have those specific IgE antibodies to those specific allergens. And then what happens? What kind of reaction do you have? So essentially, IgE antibodies are floating around in your blood. When they encounter an allergen, then they bind to a mast cell or a basophil. And essentially, those cells have special receptors on them for the IgE antibody that's attached to that allergen. The combination of the IgE antibody and then this mast cell, which is basically another just cell in our body that has a bunch of chemicals in it. When that happens, that causes that cell to release those chemicals. And so essentially you have to have all of those things happening in order for those chemicals to get released. So the IgE floating around encounters the allergen, binds to that allergen because it's specific for that allergen. Then that combination binds to the mast cell or the basophil. And then once that binding happens, that causes the release of all of these chemicals.
Dr. G, I'd love to use your analogy one more time to explain the way I see now how an allergic reaction kind of happens. And that's that you've got three parts to it, right? You've got a kid, a stick, and a piñata. And in this situation, the kid is the IgE antibody that's just like floating around the birthday party causing no problems. Then you've got the stick, which is the allergen. Let's call it a protein. So like a peanut protein, the allergen. And then you've got the piñata, which is just hanging there. When the kid and the stick come together, they are primed. They are ready to hit that piñata. And once they hit the piñata, all the candy falls out. And in our analogy, this candy that's falling out are the chemicals that cause the allergic reaction, which is kind of chaotic in your body. And in a birthday party, once, the piñata opens, the kids go crazy and it's chaos. So I think that's the best way I see it is once the three things come together, you've got this chain reaction and there's the release of chemicals, which then causes all of the allergic reaction to happen.
Exactly. That's a great analogy, Courtney. And I'm glad that we brought it back into this episode. And then the chemicals that are coming out, one of the most important chemicals that we've talked a lot about is histamine. So histamine is one of the main chemicals that's released when the piñata is broken and releases all those chemicals. And that piñata, again, is the basophil or the mast cell. So one of the key things to remember is that histamine causes vasodilation or causes the blood vessels to dilate or get bigger. That can be a good thing in certain times, but when that happens too quickly, the blood can't get moved back up into the heart and brain, which is super important. We need blood flow to those areas at all time. We need blood flow to all of our body. And so whenever we get the blood flow not reaching our heart and brain, that can cause those areas to stop working. And so that's essentially what can happen during an anaphylactic reaction when too much histamine is released. Histamine also causes inflammation or swelling all over the body. And then there's lots of other chemicals that are released during an allergic reaction. So all of those chemicals essentially put together cause the symptoms of runny nose, itchy eyes, wheezing, shortness of breath, vomiting, diarrhea. All of those things can happen all at once, and that can be very scary.
And one more thing I've heard a lot, because we just talked about IgE, but another thing I've heard about when we talk about an allergic reaction is Th1 and Th2 immune response. I'm actually really not sure what those are. Could you explain those and why they're important in an allergic reaction?
Yeah, so this is terminology that we use as doctors and scientists, but Th1 and Th2 refer to the way that essentially we categorize the immune response. So Th1 responses are typically involved in fighting off viruses and bacteria, and Th2 responses are associated with allergic reactions and fighting parasites. So with atopic or allergic people, there's a tendency to have more of that Th2 response, leading to increased production of IgE antibodies. So that's really the connection with what we've discussed. If someone is producing IgE antibodies, that means that they're leaning towards an immune response that we would call a Th2 response and not a Th1 response.
Okay, so basically a Th2 response from the immune system is creating IgE antibodies, and those again are specific to what you're allergic to. So one other thing I wanted to ask you really quickly is that you mentioned that food allergies and environmental allergens have different responses. And when a lot of people think about an allergic reaction, they think also about bee stings or wasp stings. So they think about venom. How do food allergies, venom allergies, and environmental allergies all differ if they do?
The symptoms for environmental allergies, drug allergies, venom allergies, food allergies are all going to be different. For drug allergies, venom allergies, and food allergies, those can all lead to something called anaphylaxis, whereas environmental allergies do not cause anaphylaxis. So anaphylaxis is a severe reaction that's caused by, again, the release of all of those chemicals from the mast cells and basophils quickly and in a more profound way. And it's likely because of the way that our body is exposed to these allergens. So for drug allergies, food allergies, and venom, it's actually a direct exposure into the body through the gut and the blood. Whereas for environmental allergies, that allergen is encountered through the respiratory tract or the skin. So when we eat food, it goes into our mouth and goes directly into our GI system. And all of these different cells are involved in absorbing that food into the body quickly. That's what happens with food. Same thing with a drug. Either it's given by an injection right into the bloodstream, or we take it orally and it goes in through the gut. And again, there's so many cells that are responsible for absorbing whatever we put into our mouth. And then for venom, that is when a bee or a wasp sting and put that venom into our bloodstream directly. And so again, all of these different exposures yield different symptoms. So when you have environmental exposure through the skin or respiratory tract, it can cause itchy eyes, runny nose, congestion of the nose, itchy skin, hives, and it can also lead to allergic asthma, which can cause difficulty breathing and can be scary. And if you don't have controlled asthma, that can lead to a very scary, possibly fatal outcome, but it's not that common. Usually it's not a life-threatening reaction. With food, venom, and drug allergies, you can have anaphylaxis, which is again, the rapid release of chemicals can cause so much release of histamine and all of these other inflammatory chemicals that you can get a very rapid decrease in your blood pressure, which means that you reduce the blood flow that's getting to your heart and brain. And then it can cause so much inflammation so quickly in your airways that within minutes, you can have a complete closure of the airway. It can also lead to that vomiting and diarrhea, which again reduces the amount of fluid that's in your body, and that can cause reduced blood flow to your heart and brain. So all of these things happen so quickly when you're exposed to food, venom, and drug allergies because of the way they enter your system.
That's really interesting. So I'm curious, if you don't mind me digging a little bit deeper, is an environmental allergen, so like a dog or pollen, they end up coming into you through your nose or your mouth, I guess, when you're breathing it in. You're not swallowing it in, you're breathing it in, or it's on your skin. So does that mean that an environmental allergen won't give you like any stomach problems or like blood pressure changes?
Exactly. So the key thing to remember here is that environmental allergens do not cause anaphylaxis.
And to be clear though, not every food, venom, or drug allergic reaction will lead to anaphylaxis, right?
Yes, that is true. But we always have to be prepared for anaphylaxis at any time when we have a food or venom allergy. And that means that we have to carry around our epinephrine device because that's really the only device that can stop anaphylaxis from happening. But one thing to remember is that every reaction can be different and it can depend on a lot of different factors. So, for example, if you're sick and your immune system's not doing well in general, your immune system might actually respond even to a lower threshold than maybe you did the day before or another point in your life. And then the other one is how much food were you exposed to? And even that can vary in terms of you may have a reaction with a small amount of food one time, or you might require more exposure the next time. So it's very unpredictable. And that's why we say zero exposure and always be prepared with your epinephrine device.
You just dispelled a myth that I've heard a lot, is that the next reaction will be worse, but it sounds like it's really very nuanced. There's a lot of things that can come together to determine how severe the reaction is, not just how much allergen you eat, but basically what's going on in your body as well.
Yeah, and that's true. And I want to just make a point that I think that the reason that we would say that, or that people have thought that, is because we can produce more IgE antibodies. Every time our body is exposed to an allergen, our immune system says, okay, we need to be ready for this again next time. And so you might actually have more of those IgE antibodies floating around for that particular allergen. So technically, our reaction could get worse the next time. But again, it depends on so many different factors. And so that's just what's important to keep in mind.
Great. And I just want to reiterate, the key thing to remember here is that environmental allergens do not cause anaphylaxis. So now we have a really good idea of an allergic reaction, right? We know what an IgE mediated allergy is. Now, Dr. G, I would love to know the difference between an allergy and an intolerance.
So that's a great question. A food intolerance doesn't involve the immune system. It's when your body has difficulty digesting or metabolizing certain food. And sometimes it's due to a lack of a specific enzyme. And a common example of this that many people have heard of is lactose intolerance. So lactose is just a sugar that is contained in milk, and we need, in order to be able to digest it appropriately, we need this enzyme lactase. That's one example. In addition, food intolerance generally involves the digestive system, and the amount of food ingested is directly linked to the amount of symptoms that someone's going to have, or the severity of symptoms. And the food causes similar symptoms with each exposure. So what I mean by that is, again, I'll use the example of lactose intolerance. When people eat something with lactose and they don't have that enzyme or a sufficient amount of the enzyme lactase, then some of the common symptoms that they might have are bloating, gas, and diarrhea. In contrast, food allergies involve the immune system, and specifically IgE-mediated food allergies, just to be very particular about the terminology that we're using. Even tiny amounts of the food can cause a severe reaction for the person if they're truly allergic. And finally, IgE-mediated food allergic reactions are unpredictable and they have the potential to progress to anaphylaxis. They can involve symptoms of the digestive tract like vomiting and diarrhea and things like that, but it's not just involved with the digestive system.
Okay, so what I'm hearing is that a food allergy is something that happens in the immune system, whereas an intolerance happens in the digestive system. And it's two different systems in the body reacting, right? So for a food intolerance, there's not enough of an enzyme to break down the food, and that's what's causing the reaction. Whereas a food allergy, something in the immune system is reacting, and that's what gives us this life-threatening symptoms. And that's why it happens in more systems in the body than just in the gut.
Exactly. And it is important to make that distinction early on so that people know that there is a difference between an allergy and an intolerance.
You can have an intolerance and you can have a food allergy, right?
Absolutely. You can have lactose intolerance and also be allergic to peanut and have an IgE mediated food allergy.
I understand lactose intolerance. I've heard that a lot of the times, but I know that in my family, I am personally banned from eating broccoli because it gives me symptoms that are very similar to what you described with a lactose intolerance. And I want to know, is that also a sort of intolerance? Can we get into that just a tiny bit more?
Yes. So that's an example of an intolerance too. And different people have intolerances to different foods, but broccoli in particular can cause gas and bloating and all of these types of symptoms because broccoli has a different type of sugar called raffinose, and the body can't easily digest that either. And so instead, the gut bacteria ferment the sugar, leading to the production of gas and bloating. That fermentation leads to all of those symptoms. So although this is uncomfortable, it sounds like for you and your family, it is actually obviously not life-threatening, and you've experienced a life-threatening IgE mediated food allergy. So you personally know the difference between what those two feel like. But the reason that we wanted to bring this up today is because it's really important to use these terms correctly. When we overuse the term allergy instead of using the word intolerance, that can cause a lot of confusion. And that's really where we are now. So people have used the term allergy when they really mean intolerance. And when that happens over and over again, and someone has an intolerance to broccoli, for example, like you, and then they go to dinner and maybe they tell the waiter at the restaurant that I can't eat this food because I'm allergic to it. But then they see you picking off of your husband's plate and eating some broccoli just to try the dish, and they see that you don't have that life-threatening reaction. It makes that person not take allergies as seriously as they should. Moving forward, they might not be as vigilant because they see people eating these foods and nothing happening. And when somebody's truly allergic, you can't do that. When they have a true IgE-mediated food allergy, the body can have a very severe reaction, even with tiny amounts of that food being exposed to that person's body. And that's why it's really important for people to be very vigilant when someone tells them that they're allergic to something. But again, if we're using the terms interchangeably, then it does cause confusion for people. And so to me, it's very important that we make this distinction in today's episode, because I want to make sure that moving forward, people really focus on using those words carefully, because it can make a difference in the way that people react to how they're handling food and managing food allergies in their restaurant or even in someone's kitchen.
Yeah, 100%. I cannot even tell you how many times this has happened to me in a restaurant. First off, you'll never see me ever picking off any other plate because I know that that's not a safe option for me. I don't know if they've handled the dish the same way as they've handled my dish. So I would never, even if it's like 100% allergen free, I would never eat off someone else's plate. And that's because I specifically tell the restaurant that I have food allergies, and I have my little allergy card with me that distinguishes a food allergy from an intolerance. Really, it does. But what's interesting is actually I've had quite a few experiences recently where someone at a restaurant will ask me if I have anaphylaxis. They'll even use that term. And I'm always really shocked when a waiter says the word anaphylaxis. And my gut instinct is to say no, because I'm afraid they're going to kick me out, like that they're going to say we can't serve you. But most of the time they say we ask that because there's too many people who have intolerances who use the term food allergy. And when we know that someone comes into our restaurant with anaphylaxis, we have a totally different set of protocols than when someone has an intolerance.
Wow, that's really great. And that's an elevated wait staff or elevated restaurant, because that really is an important distinction that we need to make between what is a true IgE-mediated food allergy that can lead to anaphylaxis or what is an intolerance that just leads to uncomfortable symptoms. And the fact that they understand that they need to take one more seriously than the other is really important. And obviously, some people can get really uncomfortable from even a food intolerance. So we need to take both seriously, but one can be life-threatening, whereas the other one is not.
Okay, Dr. G, thank you for explaining intolerance. Now I'm going to throw one more thing at you because this is another situation that kind of gets complicated in restaurants. And that's because I can eat cooked carrots, but I can't eat them raw because it makes my mouth super itchy. So I always tell restaurants, please, no raw carrots in my salad, but it's okay if they're cooked in the pasta. And they look at me like I'm crazy. And I'm like, yeah, I don't know. One I'm allergic to, one I'm not, and it's something to do with protein. Can you explain a little bit better than my obvious crappy explanation to a waiter?
Yes. So what you're talking about is oral allergy syndrome. And what that is it is technically mediated by those IgE antibodies that we've been talking about. But what your body's actually doing is it's reacting to a protein in the fruit that looks like a protein in the environmental allergen that you're allergic to. So in foods, there are a lot of different proteins, okay? And that's what makes up any type of food. And there is what we call a dominant protein in the food that's more likely to result in an anaphylactic reaction if you're truly allergic. And so we figured out what is that dominant protein in each food. And that's what we're testing for when we're testing your blood for those different food allergens. Then there's all of these other proteins in the food that are there, but they're not as dominant, and they're not the thing that is going to lead to a whole onslaught of those chemicals being released. And so when you have an environmental allergy, there are certain proteins in fruits and vegetables that can look like that environmental allergy protein. And so your body's like, wait, I think this is the tree that Courtney's allergic to, and she's eating that tree because it looks similar to that tree protein allergen. So your body's releasing some chemicals, and that's why you're getting that itching in your mouth and that discomfort in your mouth. But it's not going to have that anaphylactic reaction because it's not the main protein in the food. So I hope that makes sense. So your body is reacting to something, but it's not going to lead to that huge release of chemicals that can be life-threatening and cause a severe reaction. So oral allergy syndrome, again, is generally just limited to itching in the mouth, a little bit of itching on the tongue, maybe some discomfort at the back of the throat, and it shouldn't lead to anaphylaxis.
So just to clarify what you said, to make sure I understand this correctly, is that there's a protein in the carrot that looks very similar to the protein of the tree that I'm allergic to. And so when I eat the carrot, my body sees this protein and it's like, hey, is this like the one from the tree that she's allergic to? And so because they're so similar, my body then decides to react to it. Is that correct?
Yes, that's absolutely correct. And I wanted to mention, because I know you talked about being able to eat heated carrots and not raw carrots. And so when you heat something, when you heat a food, it actually changes the way that the protein looks to your body. And so those minor proteins that are in that food get changed enough where it doesn't look like the protein in the tree. And so your body's not going to react to it. So that's why you can eat cooked apples or cooked carrots if you have oral allergy syndrome to those foods, because it changes the protein enough so that it doesn't look like the environmental allergen.
Thank you so much, Dr. G. I hope that you guys have a little bit more clarity. I know that it is so helpful for me to see how things are working in my body and understand a little bit better about what is going on when I encounter things like peanuts, dogs, and broccoli.
Thank you for listening to today's episode. Remember that all information you hear today is for informational purposes only and are not intended to serve as a substitute for the consultation, diagnosis, and/or medical treatment of a qualified physician or healthcare provider. And also, don't forget to subscribe to our podcast. And if you have a second, help spread the word by rating our podcast and sharing with your friends and family who might also be interested in learning more about allergies, asthma, and immunology. You can always stay up to date by checking out our Instagram, The Itch Podcast, where you can leave questions you are itching to know, or check out our website, which is www.itchpodcast.com, which contains more information about the subjects we covered in today's episode and every episode. Until next time, have a fabulous week.